So today we are going to learn about the drugs which are used as sedative and hypnotics. That is, the drugs which are used to reduce overexcitement, reduce overexcitement and stress. Now in this, you know what is exactly sedatives and what is hypnotics. So sedatives and hypnotics are both are used to reduce the overexcitement and stress, but sedative is the agent which is reduces overexcitement without inducing sleep, whereas hypnotics is the agent which are also used to reduce the overexcitement and stress with inducing sleep also. Okay, remember one thing, that the drug molecule at low doses, you have to remember, at low dose, it acts as sedative, but at high dose it acts as hypnotics. Okay, this drug act as non-selective antidepressant. So non-selective antidepressant. Okay, now we are going to learn about the SAR of barbiturate. But before learning the SAR of barbiturate, first we have to understand the barbiturate skeleton. That is, what is the basic structure of barbiturate. So in the basic structure of barbiturate, you will get 2,4,6 trioxo 2,4,6-trioxopyrimidine. Now I will tell you how this is 2,4,6-trioxohexahydropyrimidine. See, the structure of pyrimidine is like this. Okay, in this, 3 double bonds are present. So when we will remove each double bond, we will put or add 2 hydrogen. So in the cost of 2 hydrogen, we will remove each double bond. So if from the structure of pyrimidine, if we are removing 1 double bond, that means like this, if we are removing this one and we are adding 2 hydrogen, that means it is called dihydro. If we are adding 4 hydrogen, tetrahydro. If we are adding 6 hydrogen, that means we are removing 1 double bond, removing another double bond, removing another double bond. That is unsaturation. So that's why it is called 3 double bond is removed, so it is called hexahydropyrimidine. Okay, now remember that this is hexahydropyrimidine. In this, numbering will start from, you know, OSNP rule. According to OSNP, first we will start numbering from oxygen, then sulfur, then nitrogen, then phosphorus. Here, which one is present in the cyclic structure? First nitrogen and carbon. So we will start numbering from nitrogen. So this is 1, 2, 3, 4, 5, 6. Okay, so that's why, see, this oxygen is present at second carbon, so it is called 2 second third oxygen. Kitna oxygen present? 3 oxygen present at number 2, 4, 6. So that's why it is called 2, 4, 6 trioxo. Did you understand? 2, 4, 6 trioxo and hexahydropyrimidine. The complete structure is pyrimidine. Okay, so you have to remember one thing. First we write 2, 4, 6 trioxo hexahydropyrimidine. You have to remember one thing, that this pyrimidine is now in barbiturate The pyrimidine is saturated or unsaturated? It is saturated. Okay, so this pyrimidine is saturated. First point. Second, the another name of this structure is, you can also call it as hexahydropyrimidine 2,4,6 trione. Hexahydropyrimidine 2,4,6 trione, because ketone group is present. You can also consider 3 ketone group. The most important point on the point of view of GPET is, which derivative is this? So the barbiturate is which derivative? Tell me. The barbiturate is amide derivative. You know what is amide? When any carboxyl group is present along with this one NH2. So this is called amide. This is called amide. Can you see this here? See, this is the C double bond O, and this is the nitrogen. So this structure is called, wait a second. So see, this structure is called amide. That's why it is also called amide derivative. And you know, cyclic amide is also called lactam. If you remember any lactam you studied, so the lactam, you may have studied beta lactam antibiotics. In this, if you remember, the structure was like this. So nitrogen is also present along with this oxygen, C double bond O is present along with this nitrogen is present. So this is amide group. This is amide, and the complete structure is a cyclic amide. Complete structure is a cyclic amide. That's why it is also called lactam. So you can say this is a lactam derivative. You can also say this is a cyclic amide derivative. You can also say this is a pyrimidine derivative. You know how it is pyrimidine derivative? You understand or not? Okay. So these are all about the barbiturate skeleton. Now we are going to learn the SAR, structural activity relationship of barbiturate. So SAR. Okay. So SAR. Okay. Can you please tell me what is the common name of barbituric acid derivative? Barbituric acid, it is also called barbitone. So the reason behind that, it has ketone as functional group. Okay. Now see, this is now start numbering 1, 2, 3, 4, 5, 6. So in this, in the fifth position, what are present? 2 hydrogens are present. Yes or no? And because of these 2 hydrogen, barbiturate is pharmacologically less active. So because of these 2 hydrogen, pharmacologically it is less active. So remember, barbituric acid is less pharmacologically active because of presence of these 2 proton at fifth position. Which position? Fifth position, or you can say C5. C5 position. Okay. Now it undergoes under 3 possibilities. That number 1, modification on keto group. So this is one keto group, This is another keto group. This is another keto group. So the modification on these three keto group, modification number one, modification on keto group. This is the first change. Second, it can also show that the modification at fifth position. So this is the fifth position. Number two, modification at fifth position. Number three or third point you have to remember is that nitrogen atom at first and third position. Nitrogen atom. So this is nitrogen. See this one. So nitrogen atom at first and third position. It can also show modification. It can also show modification. It can also show modification. Okay. So what are the three possibilities modification? Number one, modification on keto group. Number two, modification on fifth position. And number three, modification on nitrogen present at first and third position. These three modifications are possible on the structure. Okay. Now we are going to learn about the modification on keto group. So what can be happen if the changes or modification takes place at keto group? So the first thing is that at C2, C4 and C6, again, so 1, 2, 3, 2, 3, 4, 5, 6. So remember that the modification at C2, C4 and C6, if C double bond O is very essential for the activity. So this C double bond O, this C double bond O and this C double bond O, that is carboxyl group, is carboxyl group. Okay, and it is very essential for activity. Okay, so if C double bond O is replaced with C double bond S, so if this C double bond O is replaced with C double bond S, that is thio group, then pharmacological activity of barbiturate is decreased. So at that point what will happen? Decreases pharmacological activity of barbiturate. So if this C double bond O is replaced with C double bond S, are you getting my point? The structure will be like this. In this, C double bond O is there in the place of O. Now if it is S, like this 3, or it can be 2 or it can be 1. So if we replace the oxygen with sulfur, that is thio group. Okay, now it is called thiocarbonyl group. So in that time what will happen? They act as, first of all, the activity will decrease, and number two, if the C double bond O is replaced with C double bond S, then this thiocarbonyl group will act as general anesthetics. So it is written here, na? Pharmacological activity decreases, general anesthetics. This is the second most important point. Okay, next we will learn the nitrogen atom modification at first and third position. So what will happen if we change the nitrogen, or if any modification takes place at nitrogen? Okay, so first of all, the alkylation on nitrogen atom at first or third position leads to the decrease in pharmacological activity, that is like this. In this hydrogen is there na, so if this hydrogen is replaced and CH3 is added like this in both position or in one position or anywhere, the important point here is that the alkylation of nitrogen present at first or third position will lead to the decrease in pharmacological activity. First point. Okay. For example, what we have studied in the SAR in this, once you check the structure of phenobarbital and mephobarbital. So remember, phenobarbital is always more potent than mephobarbital. The third changes that can take place is the modification at fifth position only. So let's see the fifth position. So in the fifth position, two hydrogen are there. If we replace this two hydrogen with alkyl group or any other group, then what can happen? So if the two hydrogen atom are present at the fifth position, then those components are having less pharmacological activity. So because of the presence of these two hydrogen, the complete structure will show less pharmacological activity. Okay. Next, at fifth position, there should be only 6 to 10 carbon atom. Only if it increases or decreases, then the activity will also decrease. So, for example, take methyl phenobarbital. So in the what is the structure of methyl phenobarbital? The structure is like this: 1, 2, 3, 4, 5, 6. Okay. Now, in the fifth position of methyl phenobarbital, methyl phenobarbital, what will happen? You will see a benzene ring present here. Okay. Along with this, you will see a ethyl group present. Like this, you can also write single bond C2H5. So, what did I mention? At the fifth position, there should be only 6 to 10 carbon atoms. 6 to 10 carbon atoms only. If it increases, that means once you count 1, 2, 3, 4, 5, 6, 7, 8. So how many carbon atom overall? 8 carbon atom. So the range is 6 to 10. If more than 10 or less than 6 carbon atom are present in the fifth position, then it will decrease the activity. Okay. Next, the next point is, if fifth position is substituted with two alkyl group, then the pharmacological activity of the compound will increase. See here, in this, two different group are present or not. So in the fifth position, in this position, if two different atom like this or any 1, 2, so any alkyl group, if any alkyl group or two alkyl group present at the fifth position, then pharmacological activity, what it will do? Pharmacological activity will increase. Okay. Thank you.